All right, I'm going to start with going over 3.4. I know most of us already did it, but this is really for my sophomores who are out. So I have my regular sine function here. There's my unit circle. Now I'm going to look at my chart. And what I'm going to do is I'm going to fill in the chart. So the exact is basically what you memorize on the unit circle, right? So the decimal you get from just putting in the exact values into your calculator. So 0, 1/2. This is square root of 2 over 2, square root of 3 over 2. And you can notice the pattern in the way that I am doing this, that you can see it goes 0, half, square root of 2, square root of 3, 1, square root of 3, square root of 2, 1, 0. So it kind of goes in that order. And all of these down here are going to end up being negative. Because remember, sine is only positive in the first and second quadrants. I'm just going to put the negatives in before I forget, except that last one, because the last one is 0. And when you're filling out a chart like this, my recommendation would be to do all of the over 2's and the pi's, and then all the pi over 4's, right? Pi over 4 is just square root of 2 over 2. Then you can just worry about the pi of 6 and pi over 3. So there's my chart completed. Now what this is going to help me do is actually graph my data. So as you can see here, I have my graph right here. I'm going to go ahead and plot my points. So I had 0, 0, and then I am at pi over 6 is 1/2. And then I have 0.707, and then 0.86. And then at pi over 2, I am at 1. And then it's like a mirror, so I don't really have to think too much, just as long as they're kind of in the same place. And now I can go ahead and connect my dots. Okay, that did not work like I thought it was going to. So there's what my sine function looks like. Now, as you can see, it's half in the positives, half in the negatives. So now I'm going to talk about the characteristics of the graph itself. So on the graph itself, I am increasing from 0 to pi over 2. So if I'm looking at the circle, I'm from here to here. So from 0 to pi over 2. But I'm also increasing from 3 pi over 2 to 2 pi. So in this section down here. Okay, and then I'm decreasing all in this middle section from pi over 2 to 3 pi over 2. So this whole side of my circle is decreasing. So from pi over 2 to 3 pi over 2. Okay, now for concavity, I have both, right? I have my concave up and concave down. So concave up is happening in this section right here. So from pi to 2 pi. So from pi to 2 pi. We are concave up, right? And concave down is occurring from 0 to pi. So from 0 to pi, I am concave down. Okay, so that is the rules for sine, and that's how it is, unless there's some kind of transformation, but we're not even going to that yet. We're just talking about basic sine functions. So I'm going to skip the examples, but what I would like for you to do is on your own, pause the video and solve for these answers. And then on Monday, I will make sure that I have all the answers for you guys so you know if you got them right or wrong. But that's not going to be included in these videos because I do want you to do the practice. So now I'm going to do the same thing, only now I'm doing the cosines. So I have to just fill in my chart. So again, all of the exact values are going to be the ones that I memorized from my unit circle. But now notice in the cosine, my positives and negatives are kind of a little bit all over the place. It's kind of like a negative sandwich, right? I go from positives, I hit 0, then I'm down to the negatives. And I'm still in the negatives. And once again, now I'm in the positives. Because remember, cosine is only positive in the first and the fourth quadrant. So it's not going to be like sine that was nice and was all positives and then all negatives. I'm going to have a big gap in the middle, which basically covers the two quadrants, right? So from 1 to 0 is quadrant 1. From 0 to -1 is quadrant 2. From -1 to my other 0 is quadrant 3. And now this last set is in quadrant 4. So once again, I'm going to sketch my graph. So now you'll see that the graph, the cosine graph is going to look a little bit different than the sine. It's going to kind of look like like if you moved the sine graph a little bit, you'll see what I'm talking about when it's graphed. And then I'm back once more in the positives. So the cosine graph is going to look as if I had kind of like cut up a sine and only focused on one of the dips, right? So talking about increasing and decreasing, well, here's the zoomed out version of my graph. My function is decreasing from 1 or from 0 to pi. Oh, I'm supposed to do increasing first, but that's okay. From 0 to pi, I am decreasing. And then from pi to 2 pi, I am increasing. Now notice that cosines increasing and decreasing match sines concavity rules. So the patterns for concavity and increasing, decreasing on the sine and cosine functions are actually flipped. So now we'll see here in this other one, I have my graph is concave up. Well, it's concave up from pi to 3 pi. Pi over 2 to 3 pi over 2. So from pi over 2, concave up, while it is concave down in 2 sections. So from 0 to pi over 2, and then from 3 pi over 2 to 2 pi. So from 0 to pi, and then 3 pi to 2 pi. So now I'm going to go ahead and in my dark blue, I'm going to just write it out so that you all can see, so that, you can see concave up is going to match increasing. So this is sines concave up. This is sines concave down. While my concave up, now this is going to be a bit extra interesting. It's actually when my sine is decreasing. And this is when my sine is increasing. So it's like super opposite when it comes to the concavity and increasing and decreasing, right? But they have the same idea. And now again, I'm not going to do these problems, and that is the end of 3.4.